Hello all. Just now we have finished the arithmetic operators. So now we can start with the logical operators. So I think everyone should remember that when you learn the digital electronics, I can say maybe the Boolean algebra. So in Boolean algebra, we all have performed this we all have performed these logical operations, we can say. So what are the logical operation? Not, and, or, nor, XOR or XNOR. So these are the few examples of logical operators. So what these things will do, what not will we do? So not is work as a inverter. So you can see here not is working as an inverter. If my input is 1, you can see here in this image, I'll fix it to zoom, and I'll try it to zoom here. I'll close this library till that time we will zoom. Fine. Okay, so you can see here in this image. So it is working as an inverter. If I am giving input as 0, my output is 1. If I am giving input as a 1, my output is 0. So this is a logical NOT, we can say, how it will work. So and is a multiplication of two numbers. So and we are used for multiplication of two numbers, but it will work with a boolean only. So it will works with a bit only, like bit high or bit low. Bit high means 1, bit low means 0. So this all operations perform with 0 or 1 only, right? So this thing is known as like boolean things, we can say. Okay, so and here, and A into B will happen here. 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. Here you can see. Now OR is addition of two numbers. So 0 plus 0 is 0, but 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1 is 1. So here one carry is there, but we are not taking here. Okay, fine. So another one is XOR. Whatever we are doing, for that we are making the XOR. Means if my both input should not be high or both input should not be low. Like any one should be high and low or low and high. In that scenario, I will get XOR output as a 1. Okay, so you can see here 0, 1, I am getting 1, 1, 0, I am getting 1. But for 1, 1, and if my inputs are same, then my output is 0. Simple definition of XOR. If my inputs are same, then my output is 0. Okay, so you can see input are same, output is 0, input are same, output is 0. If any of the inputs are different, then output is 1. If I want to define for OR, so if my any of the input is high, then my output is high. You can see here. If my any of the input is high, here you can see it's 1 is high, here 1 is high, here both are high, then output is, but here none of high, then output is low. Definition for AND, if you want, then if my any of the input is low, my output is low. Understood now? If my any of the input is low, here 0, 0, 0, then output is 0, 0, 0. Okay, until and unless your both inputs are high, this will not become 1. So now we will learn about this thing with the logical operator block. So I am opening the library. In the library, you can see in the SIMULINK tab, there is one logic and bit operators block. In here, I am having this logical operator. This is very important thing for the MBD we have to learn. Okay, this is very basic functions. Basic function, I can say how we can do and all this thing. So here you can see now maybe in your mind you are having a doubt, like here we are having only AND in this library, how we can get OR, NAND, NOR or XNOR remaining gets. So I'll show you here now. Okay, in this example only. First we will do with NOT operation maybe, or maybe like AND operation, whatever. We will see here now. How can I change this logical operator? So by default, if I am taking a logical operator, here AND is there. If I am double clicking here, so here the operators is written here. You can see here one drag down option is there. From here we can select the what gate peapod. So I am selecting NOT here and apply OK. So you can see NOT is required only one input. Okay, so maybe I'll just connect here only one. Okay, and I'll just delete till that time this one. So if my input is 1, my output will be 0 in the NOT operation. You can see I'll simulate now. If my input is 1, output is 0. If my input is 0, then output will become 1. So this is about the NOT operation. Now we will perform this AND operation. How I can perform this AND operation? I'll double click here. I'll change here to the AND. Okay, apply. Okay, if you want multiple input AND gate, you can select it from here. You can see here in the image I'm having 4 inputs of this AND gate. If I'm selecting here 4, okay, so it will work like in this way. Okay, it will come in this way. So now for the example purpose, I'll use 2 input AND only here. Okay, so I'll connect one more constant here. So now you can see if my input is 0, both the input is 0, then my output will be the 0. Now you can see it's 0. If I am trying to make any one of the input as high, like any one of out of these two, then also my output is 0. So definition of AND is until and unless my both the inputs are high, my output will not become high. This is one definition. And second definition is if my any of the input is low, then my output is low. So you can see if both are high, then my output is high. Now I'll change this to the OR gate. Okay, OR gate or OR logic, I can say in that way. Okay, so OR logical operator. If my both are 1 1, then output is 1. What is the definition for OR? If my any of the input is high, then output is high. Okay, any of the input. Okay, that means if I am making 1 as 0, okay, then in that scenario you can see my output is high only. Until and unless my both the inputs are low, my output is low. This is the second definition for the OR gate. Okay, now I'll change to the XOR here. You can see XOR. So there are two ways to change this logical operator. One, double click on this, you will get this option. Or else if you are using a latest Matlab version, you will get here drag down option on the screen only. So I'll use here XOR. So you know, if my both definition for XOR is if my both inputs are same, my output will be 0. You can see here output will be 0. If I'll change to 1 here, any one of this one, okay, now output will become 1. But if I'm making again this both are 1 1, then my output will become 0. You can see here now it become a 0 after simulation. If I'll make this one and this is 0, in that scenario also you can see here it will become a 0. Oh, okay, here it will become 1 because 1 and 0 is making 1. My both the inputs are different, then output is high. If my both the inputs are same, my output is low. So this is a definition for XOR. Okay, so this is all about the logical operator. In next session, we will learn about the comparator operator or relational operator for this. Okay, that's it. Thank you.